Hello guys, welcome to a new video. In this video, I'm going to be talking about the area and we'll be looking at the area of quadrilaterals. I'm going to start by looking at the rectangle. This side here is called the length and this side is known as the breadth or the width, as some would call it. Next, we're going to have a trapezium where we have these two lines being parallel to one another. So that is A and this is B. And then what we have here is known as the height. And lastly, we're going to look at a kite, where from point A to point B right here, this is known as A. And then we have the height, which is that top part and the bottom part. And this is known as the height, or we'll call it B. The formulas for the rectangle, for finding the area of a rectangle, we say length times breadth, or some know it as the length times width. And then when we're looking for the area of a trapezium, we say 1/2 multiplied by A plus B multiplied by H, which is the height. So the A, as I've said, the A is this part, the B that we're talking about is here, which is this length from this point to this point, and then the height is shown right here. And then the area of a kite is found by saying half multiplied by A times B. This is the A and this is the B, as I have shown right here. I'm going to look at a couple of examples where we're going to find the areas for each of these three shapes. Example number 1, we have a kite and we're asked to find the area of this kite, whereby you can see the two diagonals, 3 centimeters and 6 centimeters. So we're going to plug in the formula for finding the area, which is equal to half A times B. Then we say half multiplied by A. You can take either A to be 6 or to be 3. It's still fine. A is going to be 6 multiplied by 3. Half times 6, that is 3 times 3, which is equal to 9 centimeter squared. So do not forget to put the squared when you're dealing with the area. Number 2, we have been given this diagram whereby we have A and B. And from what we can deduce from this, A is a trapezium and B is a rectangle. We have this side 3 meters and the one with 5 meters being parallel to one another. And then we have the height, the total height being 7 meters, and we have the other side from this point to this point being 3 meters, and we're asked to find the area. So what I'm going to do is to find the height of this trapezium first, and we're given the total height as 7 meters and then the height of the rectangle as 3 meters. So to find, I will just call it H. To find H, we're going to say 7 meters minus 3 meters, and then we get 4 meters. That's the height for the trapezium. Now, moving on to finding the area of the shape A, I'll call it area A, which is a trapezium. I'm going to say half A plus B multiplied by the height, which gives me half. My A is going to be 3 plus my B is 5 multiplied by H, which is what we just got as 4. Now, half times 4 is 2, and then 3 plus 5 is 8. So 2 times 8 gives me 16 square meters. And I'm going to go ahead and look for the area of the shape B, which is the rectangle, and that is length times width, which is 5 times 3, and from this I get 15 square meters. Now the total area of the entire shape is going to be 16 plus 15, which gives us 31 square meters. That's the area of the shape that we're given in example number 2. Moving on to example number 3, we are given a rectangle, but there is something that is different here. The units are different. We have centimeters and another centimeter, and we have meters. The first step that I am going to do is to change the units of these centimeters into meters, and I get 1.3 and 1.2 meters. I will go ahead and find the area. The entire shape here, despite the fact that it is divided into 2, the entire shape is a rectangle. Hence, the area of a rectangle is the length times the width, which gives me 0.5 meters multiplied by 1.2 meters, and I get 0.6 square meters, which is the area of this shape. Number 4, please forgive my drawings. They may not be perfect, but I think it is clear what I'm trying to communicate right here. Number 4, we are asked to find the area shaded, and we can see that we have 2 shapes that are involved. We have a kite, which is unshaded, and we have a rectangle that is on the outside of the kite, which is shaded. So what we're going to do, we're going to start off by looking for the area of the rectangle, which is given by saying length times width. And from this we get 9 times 4, which is equal to 36 square centimeters. Then we find the area of the kite, which is equal to half A times B. And from this we get half. Our A is 9 and our B is 4. Half times 4, that is 2. 2 times 9, we get 18 square centimeters. So we have these 2 areas and we want the shaded area. Hence we say the area of the rectangle, this one, minus the area of the kite, and we get 36 centimeter minus 18 square centimeters to get 18 square centimeters. This is the answer, example number 5. From the diagram that we've been given right here, we can see that we have a rectangle which is running from this point to this point and this point to this point. And I'm going to get the total of length, which is 6 plus 3 is equal to 9 meters. That means this point right here is 2 meters. And we also have this side as 5 meters. To find the area shaded, we are going to say the area of the rectangle is the length times the width, which is equal to 5 times 9, and that is 45 square meters. And then the area of the trapezium, which is given by the formula half A plus B multiplied by the height. Our A is 3, and then our B is 7 multiplied by 5. And from this we get half. 3 plus 7 is 10 multiplied by 5. 5 times 5, that is 25 square meters. Hence, the area shaded is equal to 45 minus 25, and we get 20 square meters. That is how we find the area shaded. Just one more example. A kite of area which is equal to 40 square meters. One diagonal is 2 meters longer than the other. Find the length of the diagonals. I'm going to let x be the length of one side and x plus 2 be the length of the other side. And we know that the formula to get the area of a kite is half A multiplied by B. And we're told that the area is equal to 40 square meters. So I'm going to say half, my A is x, my B is x plus 2 is equal to 40. Then I'll get rid of this fraction right there So we multiply everything by 2, and I remain with x multiplied x plus 2 is equal to 2 times 40, that is 80. X squared plus 2x is equal to 80. I'll take 80 to the other side so that I remain with a quadratic equation, and that would be x squared plus 2x minus 80 is equal to 0. Then I'll look for two factors such that if I multiply them, I get negative 80, but if I add them, I'll get a positive 2. And they're going to be in this format of x is equal to 0. And those two factors are 10 and negative 8. So that's x plus 10 and x minus 8. Then we get x plus 10 is equal to 0, or x minus 8 is equal to 0. That means x is equal to negative 10 or x is equal to positive 8. We can't have a length of a negative number such as what we have here with negative 10. So that means our x is equal to 8 meters. Remember, we have x and x plus 2. So that is going to be x plus 2, which is 8 plus 2, and we get 10 meters. The two diagonals are 8 meters and 10 meters. That is how you deal with these shapes. See you in the next video.